everyone. So again, today we have Dr. Sidhu with us, who is a researcher, licensed and certified AP chemistry teacher, an educationist and academician in America. Dr. Sidhu today is going to tell us about the classification of matter. So Dr. Anu, how are you?
I am fantastic. How are you?
I'm good. So let's begin from where we left off about matter. How matter is classified?
Matter. Yes, we started with matter in the last session. Are you ready to start with the another session for matter? So
Yes,
we
we
discussed
would love
about
to hear
matter.
you again.
Okay. So we started with matter. What is matter? I will just review a little bit about that. That matter is everywhere. Second is matter has mass and it occupies space. And last but not the least, matter is conserved. Matter can neither be created nor destroyed. And watch me, I'm going to ask two very, very important questions in the end of the session. So be ready and be attentive. So the first thing is, as you ask me that, how you classify matter? Matter has two categories, main two categories, that is pure substance and mixture. Pure substance and mixture. These are the two categories of matter.
Okay. So what are pure substances you mean in chemistry?
Yes, look, in day-to-day life, we say pure means which is not dirty, right? Like we have pure water, we should drink pure water, right? Look, clean. So in layman language, we say clean means something which is very pure. In chemistry, pure substance means that a substance which is made up of same kind of particles. Same kind of particles. Like for example, I talk about carbon dioxide. Carbon dioxide is made up of one carbon atom and two oxygen atoms. And what are the sources of carbon dioxide? When we exhale, carbon dioxide is released. And that carbon dioxide is one carbon and two oxygen. From the volcanic eruptions, carbon dioxide is released. That carbon
Mhm.
dioxide is also one carbon and two oxygen. From the automobile combustions, the gas which is coming out as a pollutant, that is again carbon dioxide made up of one carbon atom and two oxygen atom. So what I want to say is that irrespective of the source of carbon dioxide, where the carbon dioxide is coming out from, where because of our respiration or from the volcanic eruptions or from the automobile exhaust, it is always CO2. It is always made up of same type of particles, irrespective of the source. Another example is like water. Water is made up of two hydrogens and one oxygen. That is
Mhm.
H2O. Water coming from your tap water, that is again H2O. Water coming from my tap, the tap water here, again H2O. Pond water, river water, lake water, sea water, it is all H2O, made up of same type of particles, hydrogen and oxygen. So that is what is meant by pure substance. Like for example, glucose. Glucose is made up of carbon, hydrogen and oxygen. C6H12O6. You go to your grocery store and you want to buy glucose, glucose, that box, you will see that it is made up of carbon, hydrogen and oxygen. Here also, if I go to CVS pharmacy or I go to Walgreens and I want to buy that glucose box, that glucose is made up of carbon, hydrogen and oxygen. So whatever the resource is, the pure substance is made up of same type of particles.
That was a very clear explanation about the pure substances. Let's move forward. So, what is a mixture?
Mixture is entirely different from pure substance. Look, mixture is basically made up of two or more components mixed in any proportion by mass. For example, I have tea in this cup. It's a green tea. So if I add 1 spoon of honey and I will mix this, that will be a mixture. I
Mhm.
can add 2 spoons of honey in this. Again, that is a mixture, right? So it means a mixture can be made, it is made up of, like if you add any substance in any other solvent in any proportion by mass, that is the mixture. That is a mixture. And mixture, I will go into the little detail about that mixture also. Then mixture is two types. It is homogeneous mixture and heterogeneous mixture. So if the component which you are dissolving, it is completely dissolved and you are not able to see the particles through your naked eyes, then that is known as the homogeneous mixture, which is called solution. Like we have sugar solution, we have salt solution, we are not able to see the particles through our eyes, right? And then we have the heterogeneous mixtures where we are able to see the suspended particles like dust particle in water, maybe sand in water, chalk powder in water. That is known as the suspension. So we have homogeneous mixtures, which are called solutions, and we have heterogeneous mixtures, which are called suspensions.
We got to know about pure substances and mixtures. So how do they both differ? How pure substances and mixture differ?
Oh, yeah, very, very interesting question. Yes. So look, pure substance, as I gave you example of like, let's start with water again. Water is as an example. So water is made up of two hydrogen and one oxygen. Whatever the resource of water is, right? Like pond water, lake water, sea water, mm, any resource, it is two hydrogens and one oxygen. It means pure substance is made up of same kind of particles, which are, that's very important, which are combined in fixed ratio by mass. It will be always two hydrogen atom and one oxygen atom. It is not like in your house it will be three hydrogens and seven oxygen for water. It's not like that. It will be always two hydrogens and one oxygen. So to cut the story short, remember, like I want my audience to remember that pure substance is made up of same kind of particles, but they are combined in a fixed ratio by mass, irrespective of the source. In mixture, they are made up of two or more components. Here, the components are mixed in any proportion by mass. You can add 1 spoon of sugar in water, again, that is a mixture. You can add 2 spoons of sugar in water, again, that is a mixture. So that is a very, very important difference between pure substance and mixture. Another important difference is that if you have to separate hydrogen and oxygen from water molecule, I'm just taking that one very simple example. You cannot hammer the water molecule to separate hydrogen and oxygen, right? It means the components which are making the pure substance, we are not able to separate it by any physical process, like by hammering or by distillation. If you want to filter, you cannot, by filtration, you cannot separate hydrogen and oxygen. So we need some chemical processes to separate hydrogen and oxygen from water. And like, for example, to separate hydrogen and oxygen from water, we use the process of electrolysis. By passing electric current, hydrogen gas and oxygen gas, they are separated. Like hydrogen gas is collected at cathode, oxygen is at anode, so different, right? So that is the chemical process. But mixtures can be separated. Like for example, if you have to separate sugar from water, what we'll do is that water is evaporated. Water is volatile. It will evaporate. So, but the sugar, because sugar is non-volatile, means it does not form vapors. So sugar crystals will settle down at the bottom of the beaker. So we are able to separate. So there are various physical methods like filtration. We do that in our day-to-day life. Like we have to filter tea leaves. What we do, because tea leaves are not soluble, right? Yeah. So we are able to filter that. So filtration, distillation, fractional distillation, there are various ways. These are known as the physical methods. So I want to summarize main two differences, that pure substances are made up of same kind of particles combined in a fixed ratio by mass. Whereas mixtures, they are the two components or three components are mixed in any proportion by mass. Second is, in pure substances, we cannot separate the components by any physical method. We have to use some chemical methods. Whereas in mixture, the components can be separated by any physical method. Any physical method. Last but not the least, well, quickly, I want to tell one more difference, that the the components which are making the pure substance, they retain their property. I'm so sorry. They do not retain their property. They do not retain. Like for example, hydrogen gas is highly combustible. It has very low ignition temperature. Hydrogen gas is a very good fuel, okay? And oxygen, it supports the combustion. Hydrogen catches fire very easily, and oxygen supports the combustion. But when hydrogen and oxygen, they react with each other, we get a new compound, that is water. Water is not combustible. Water does not support combustion. Rather, it is a different property. Water acts as a fire extinguisher. So you see that the components, the starting material, it does not retain its property. Same, like one example is like sodium metal. Sodium metal catches fire when it is dipped in water. That is why we have to store sodium metal in kerosene. And when sodium metal, it reacts with chlorine. Chlorine gas is kind of a disinfectant. We use chlorine gas in swimming pool, because it is kind of a disinfectant. So chlorine gas is poisonous. No, we cannot inhale the chlorine gas. We cannot eat sodium metal. Sodium metal catches fire with water. But when sodium and chlorine, they react, we get sodium chloride. And sodium chloride is the common salt which we are using in our day-to-day life. Sodium chloride, that salt, does not catch fire in water. It dissolves in water, right? Yeah. So the components, they do not retain their property. But in mixture, sugar is sweet in taste. When we dissolve that sugar and we drink that sugar solution, again, that is sweet in taste. So the components of the mixture, they retain their properties.
Wow, amazing. You do make learning chemistry so fun. Dr. Sidhu, you have a wide range of viewers. So what question, or do you have any questions for your audience?
Okay, for my viewers, I have 2 questions today. They are super easy questions, but all my viewers, they need to pause and ponder about those questions. And I will say that this is kind of a research topic for my viewers. Okay. My first question is, who created matter? Because I know the answer actually. I just want to know the answers from my viewers. So I will collect the data for all the answers which are coming from the viewers. Then I will come to, we all will come to some conclusion. Who created matter? That is my first question. Second is, how matter was created? So I'm going to repeat my questions again. Who created matter? And my second question is, how this matter is created.
Okay. Thank you, Dr. Sidhu, for sharing this informative, knowledge about classification of matter. We'll continue this in the next session. Hope you guys enjoyed and benefited from today's session. We will continue to hold such sessions based upon your feedback as well. Please like and subscribe Dr. Sidhu's Academy and Outland Media on YouTube. This is Komal Seth from Outland Media signing off.